This video, part of a Mission Critical series, is a presentation of the webinar titled Microwave RF Cable Assemblies, the Paradox of Coaxial Cable Performance and its Impact on Operational Readiness. The presenters are Chris Ericksen and Jim Foreman.
Hello everyone, my name is Chris Ericksen and I'm a 14-year Gore associate. I've worked on wire and cable products my entire career, mainly addressing signal integrity in both high-speed digital and RF microwave. Over the last 6 years, I've been working as an application engineer and now a product specialist for Gore Aerospace and Defense. This has allowed me the ability to meet and work hand in hand with prime contractors and end users, to listen and help address the issues they face. These experiences have in part contributed to this webinar. If you are watching this webinar archive or listening to the podcast version, we encourage you to share this with a colleague or on social media.
Thanks, Chris, and my name is Jim Foreman. I've been at Gore for 27 years and working in the broader aviation world for over 38 years. I served in the Air Force for 9 years as a maintenance technician before working at BAE Systems on Tornado Avionics, helping to enhance the aircraft's capabilities before Operation Desert Storm in 1991. During my time at Gore, I've drawn on my own military experiences and managed 2 microwave RF cable development projects that have led to Gore being specified on many key aircraft programs in both North America and Europe. We're both really excited to discuss the underlying paradox that exists in the complex world of microwave RF cable performance, and we really appreciate your investment of time in this mission-critical subject.
Many of you are probably familiar with the Gore brand, specifically Gore-Tex, but most are not aware of everything else we do, or that Gore started by making cables 60 years ago. Today, Gore is a $3.5 billion international company focused on material science, specifically the development and application of fluoropolymers. Much like the Intel Inside sticker on your computer, Gore's products are embedded in a wide variety of technical applications, ranging from implantable medical devices to as far-reaching as the Mars rover. The common theme of our products is to improve lives through innovation and to deliver on the promise stated by Bob Gore. As an evolution to our wire and cable business, Gore also has a heritage in aerospace. Gore is qualified across a variety of platforms, through iterations of the F-16 to the flagship F-35, and have been flying for over 40 years. As a pedigree Performance A company, Gore has become known in the industry for high-quality products that deliver consistent and reliable performance over time. Gore continues to lead the industry in product development, and was recently awarded the Platinum Innovators Award for Microwave RF Assemblies and the Gold Innovators Award for High-Speed Data Cables. Gore in aerospace applications. Aerospace applications are some of the most demanding due to extreme environments. Gore offers an impressive range of mission-critical products in aerospace, impacting everything from threat detection and jamming to reliable communications. Our portfolio includes a variety of RF microwave cable assemblies, from small, high-density in-the-box cables to low-loss, ruggedized airframe-qualified assemblies. We also offer a multitude of high-speed data and power cable types, which deliver a lightweight yet durable solution with reliable signal integrity, enabling advanced avionics to effectively transfer information.
A consistent theme of this webinar is operational readiness, so let's look at the definition. The capability of a unit, ship, weapon system or equipment to perform the missions or functions for which it is organized or designed. When operational readiness applies to aircraft availability and mission-critical systems or applications, the short answer is it needs to work the first time, all the time. The other key theme of this presentation is the term paradox. Not often used in daily conversation, the definition of paradox is a seemingly absurd or self-contradictory statement or proposition that, when investigated or explained, may prove to be well-founded or true. Okay, now let's review the presentation format. Over the next 30 minutes, this mission-critical presentation will be divided into 3 sections: why, how, and what. Why we're here. This section takes a look at the contested electronic battleground for microwave RF signal transmission and the various avionics systems that are reliant on reliable coaxial cable performance. We'll review what happens when RF cables fail, along with the combined responsibilities for selecting the right cables. How this impacts you. Cables are not meeting their projected service life, impacting overall operational readiness and mission success. Here we review the repercussions, specifically how install performance compares to system requirements that reference dated military aerospace standards. What the steps are to ensure mission success. First, we need to understand who influences the cable buying process and is motivated by future performance and aircraft availability. Once we know the common issues that affect microwave RF cables, we can choose the right solutions to reduce them, and ideally eradicate them completely. Now let's go back to Chris.
So let's get into why we're here. A September 2018 Watchdog report raised the alarm over military aviation readiness when the Air Force and Navy failed to meet their aircraft availability goals over a span of 5 years. The report stated that the Air Force and Navy share a variety of sustainment challenges, including the age of their aircraft. The report also revealed maintenance concerns and supply support issues, costing tens of billions of dollars annually to maintain and repair aircraft in an attempt to meet the goals for availability and operational readiness.
Mission-critical systems reliant on microwave RF signal transmission. As the military continues to advance capabilities, electronic systems become the most expensive and critical components. These avionics systems enable communications, protection, and many other complex tasks required for today's missions. Airborne electronic surveillance countermeasures, radar warning or electronic defense systems, missile approach warning systems, radar interconnects, electronic signal intelligence, and navigation communication systems. All of these are examples of systems installed on many types of aircraft that require microwave RF cables. And of course, there are different aircraft types that will have different mission goals, but all of them need microwave RF cables to transmit signals through the aircraft and between system line replaceable units. Systems also require different cable characteristics depending on their function. Active sensors may utilize cables to transmit signals with increased demands on power handling. Signal detection and satellite communications equipment have developed into Ka band and above, requiring cable performance at higher frequencies, and active electronic scanning array radars rely on consistent, predictable signal phase accuracy. In the end, full mission success can be directly attributed to cable characteristics and their effect on system performance. The battleground for microwave RF signal transmission is constantly evolving. Electronic warfare is a continual game of cat and mouse as our adversaries continually expand their capabilities and we develop countermeasures to maintain the upper hand. Today, it's imperative to dominate the electromagnetic spectrum, and mission success can only be achieved by winning this electronic war. Fully integrated systems, including electronic warfare equipment and radar communications, can provide the dominance through detection and countering of any threat in the hidden world of signals, pulses, blips and noise. Using onboard avionics, the aircraft can either passively or using an active sensor detect a threat and also have the capability to nullify or destroy it. Such is the sophistication today that these systems can operate automatically to prevent any distractions so the crew can concentrate on the success of their mission. Legacy aircraft upgrade challenges. As we previously heard, the Air Force and Navy share a variety of challenges to meet aircraft availability goals, but there's also the need to keep them at the cutting edge with upgrades to their electronic systems. So let's take a moment to consider the challenges that legacy aircraft face to keep them up to date and available throughout their service life. When inserting a new technology onto an existing aircraft, more capabilities are being added to an airframe, which has a finite amount of space. This means more equipment, sensors, cabling, etc. have to find space on the aircraft, along with important considerations for the penalties of weight growth. The position of the replacement or additional LRUs and sensors are the first consideration, as their location is usually paramount to ensure the system will function correctly. And once the equipment location is determined, the focus shifts to services such as electrical power, equipment cooling and data transmission. And finally, delivering RF signals from remote sensors to the centrally located LRUs has to be considered, which usually creates challenges with space for routing and their weight. Therefore, we end up in a juggling act of size, weight and power, which is more commonly known as swap. These cables need to be extremely low loss for their size and low weight with enough durability to endure both severe routing in tight, limited areas during installation and harsh flight conditions during service life.
So let's talk about what happens when microwave RF cables fail. Degraded performance can lead to radar systems detecting false positives or miscalculating threat location, as well as shortened range. It can also lead to increased susceptibility to jamming, potentially disrupting navigation and communications. Compromised RF performance not only degrades system functionality, but can also lead to aircraft being grounded, creating conflicts with mission operations and planning. So who owns this crucial responsibility of selecting airframe cables? Well, let's begin by looking at our key players who share in the combined ownership for mission system success. We'll start with the PMO, or Program Management Office. The PMO is responsible for defining the mission system requirements with regard to what the system itself needs to do. They are not considering the types of RF cables that will be used on the system. The OEM then takes these system requirements from the PMO and creates specifications, including defining the RF link budgets. They are often responsible for selecting and purchasing the cabling that becomes part of their LRUs, sensors, and antennas. While the OEM qualifies their own LRUs extensively, they often do not go to the same extreme with the airframe cabling connecting these boxes and components. The most they normally do is specify cables that they believe meet the qualification standards and loss budget on paper, or at best directly out of the box in lab.
The integrator, who could also be the OEM in this scenario, has delivered to the specification. And this will have involved installing the system, including the cables, and then validating that it all works through performance testing. When the aircraft is finally delivered to the military unit, they will then develop their procedures to maximise the system's performance in operational environments. And the maintenance officer has to live with the cards he's been dealt and ensure he can keep serviceability rates at the levels required by the flying programme.
Now moving on to how this impacts you. Defense News recently reported that the former Secretary of Defense, Jim Mattis, issued a memo to the Secretaries of the Army, Air Force, and Navy to get mission-capable rates for key tactical aircraft up above 80% by the end of September 2019. Mattis also wanted to see a reduction to operations and maintenance costs beginning in FY19. With a clear focus on operational-ready aircraft, let's think about what percentage of RF microwave cable assemblies must pass OEM specification for a system to be considered full mission capable. Put simply, 100% equals all cables. Failure equals one cable. After installation and during every mission. It's important to stress that only one failing cable assembly has the ability to compromise mission success. This applies to both the installation of systems and continuous maintenance of the aircraft. Failure can be discovered in two ways. One, on the ground after installation or during pre-flight checks, which could lead to aircraft availability issues and ultimately impact mission planning. Or two, in the air. A single cable failure can cause disruption to communications, protection, jamming, etc., and put the pilot, aircraft, and mission at risk. If we're all in agreement that a cable can compromise mission success, then let's investigate what the industry accepts today with regard to reliable microwave RF cable performance. Let's look at the life expectancy for microwave cable assemblies. From a third-party survey, 330 respondents that included designers, operators, executives, program managers, and maintenance operators determined that 41% of respondents would accept a failure during installation. Similarly, 64% would accept a failure during the service life of the aircraft. There seems to be an overall acceptance that at some point, microwave RF cable assemblies will fail, either during the installation or throughout the life of the aircraft. This is in direct contrast to the aerospace industry demands that the assembly last the duration of the aircraft service life.
Cable installation challenges. When installing microwave RF cable assemblies, either during initial aircraft manufacture or during an in-service modification or enhancement, there are a number of challenges to consider. And the first consideration is space constraints. It needs to be determined if an appropriate size cable can be routed from A to B without inflicting physical damage through bending, torsion, and loads applied to pull the cable assembly through tight spaces. Also, weight sensitivity is a constant challenge. There needs to be a balance between material selection and cable design to create a lightweight cable construction, but at the same time it needs to be strong enough to resist crush or shock forces. And after this fit has been completed, electrical testing of the cable assembly is required to evaluate the performance. At a minimum, the testing should be insertion loss and VSWR, but system needs may also dictate that phase angle or delay also be measured. There are a number of tests listed here that need to be completed for either qualification or post-installation to provide maximum confidence that the specifications are being met. Cable performance in rigorous flight conditions. During service life, a microwave RF cable assembly is exposed to the rigorous environments that an aircraft experiences throughout its operational life, both on the ground and in the air. A cable assembly is subjected to a variety of dynamic stresses in flight, including vibration, flexure, and load forces. And also, a cable assembly could be potentially exposed to various liquids or gases that could impact its performance if these contaminants were to penetrate the cable or connectors. Mission profiles also expose the cable assembly to thermal extremes and pressure changes. And it's also important that the cable assembly doesn't support combustion or produce toxic smoke in case of a fire on board the aircraft. As we talk with various stakeholders, we're struck by how many times we hear the phrase, "The cables just have to be good enough." For the maintenance officers out in the field, how does the statement "just good enough" truly impact their ability to deliver full mission-capable aircraft? And do these series of qualification tests effectively reproduce the operational environment that the cables will need to endure in the installed condition over service life? So let's look at this from the OEM's perspective. Qualification testing should be capable of replicating the actual service conditions existing on the aircraft, ensuring the microwave RF cable assembly will withstand the rigors of flight, but also to confirm they don't add any additional safety risks to the aircraft or crew. Many of these tests are defined in military standards, some of which are outdated or not specific to cable assemblies, having a broader applicability to electrical and electronic components. The microwave RF cable specification, which is developed specific to the aircraft and the system, will reference the relevant MIL standard tests and also include the required performance levels for each test. Here is where the paradox begins. Although we can recognize that microwave RF cable design has progressed over the last 40 years, the majority of cable specifications continue to reference military standards that were created in the 1950s and 60s and have had few updates since their initial composition. Meanwhile, the maintenance officer needs to support the daily flight operations by having the right number of serviceable, mission-capable aircraft on the flight line at the appointed time, and trying to juggle scheduled maintenance requirements along with any unserviceability and still produce enough aircraft to meet the daily flying program keeps him exceptionally busy. And when faced with an avionics fault, hopefully the technicians can troubleshoot the problem and identify the course of action to get the aircraft back to a serviceable state. And this might mean it's as simple as just replacing a defective LRU and then running some built-in tests or functional testing to quickly return the aircraft to the flight line. And when the fault diagnosis points towards microwave RF cables, be it wiring or connectors, it's then more difficult to determine the downtime for the aircraft. Can an effective repair be made on the aircraft? Will the cable need to be removed and a replacement item sourced and fitted? What other systems will be disturbed during the replacement fit and the knock-on effects for testing and getting the aircraft back to a serviceable state? It's easy to see that these are potential headaches that the maintenance officer can do without. And just imagine the frustration for the maintenance officer, technician and the squadron if after replacing the microwave cable assembly in the aircraft, they discover it's been damaged during installation and has to be replaced again.
So now we begin to see the different perspectives from the OEM and the maintenance officer. The OEM delivers a qualified solution that is passing all operational requirements levied upon them from the program office. The system, including the installed cables, is fully meeting the electrical specifications and complying with the relevant MIL standards to ensure aircraft safety and performance. Weight budgets have been met, cables are routed correctly, and the declaration of design and performance has been issued.
However, the squadron are finding cable failures in their system, which is affecting aircraft readiness. There is no military standard for real-world degradation. The avionics system suffers with diminishing signal integrity over time, caused by degradation in the cable through maintenance activity crush damage, accumulation of high-stress flight environmental forces, and contamination through leakage paths into the cable assembly. And of course, as the cables fail, the squadron has the replacement issues with difficulty in routing and potential installation damage. The outcome is we're caught in a loop where the cable assembly's installed performance and the system requirements of the cable assembly specification are not matching over time. And the result is a failure to deliver fully mission-capable systems to the squadrons over the lifetime of the aircraft, ultimately creating availability and, potentially, survivability challenges. And here is a key point to sum up the paradox. Failure levels of cables in the field would suggest that whilst the list of tests above are comprehensive and detailed, they're not providing an effective guarantee of cable performance throughout the service life of the aircraft. Now for the final section of this webinar, we'll cover what steps ensure mission success. A recent GAO report highlighted the Air Force and Navy's fleet of aging aircraft, vital planes that are often in no shape to fly. And the report stated they're operating many of their fixed-wing aircraft well beyond their original design service lives and therefore are confronted with sustainment challenges. Most aircraft types also grapple with obsolete parts, a shortage of depot maintenance personnel, and unexpected parts replacement and repairs, according to the report. It's clear that sustainability challenges are identified, but are effective solutions available to ensure mission success for these aging fleets of aircraft? So, I think in order to understand how we get better with our microwave RF cable performance on the aircraft, we need to better understand where we are now, especially with respect to the cable selection process, and that starts with the OEM.
As the OEM, in addition to performance, I'm focusing on cost and schedule to ensure that I'm meeting my contractual obligations. With that in mind, I choose the cables that meet the performance spec'd out in my link budget, and then focus on delivering my system on time. Given that cables often meet the spec when delivered, problems with installed performance don't always appear right away.
As the maintenance officer, my number one focus is to keep that aircraft fully up and ready to fly. And when I experience cable failures on the aircraft that are due to the inherent operational wear and tear or through other inadvertent maintenance activities, I can't send that aircraft out on a mission. Right now, my only option when a cable fails is to replace it with the same cable as specified by the OEM, even though I don't have a high level of confidence that I won't need to replace it again in the near future. And this is especially true if it is susceptible to damage when I install it. And that's a huge challenge for us maintainers.
Absolutely. Unfortunately, the OEMs don't always get direct feedback from the maintenance officer and the flight line maintainers. We need to know when good enough isn't good enough with respect to these critical systems and the cables that support them.
As the maintenance officer, the key to overcoming these challenges is to ensure that good enough is realistically a quantifiable metric. Going forward, there needs to be an understanding at the OEM level that contract performance at delivery should extend to performance after installation and delivery and throughout the operational life of the platform.
Based on the discussion, it would suggest that good enough for the OEM may not translate to good enough for the end user.
Ideally, there would be a shared decision-making process for cable selection, in which the feedback from the end users would be incorporated into the written system requirements from the beginning. And this would allow the OEM to potentially make better decisions with regard to cable selection.
Exactly. As the OEM, we should be looking at cables that meet all the demands of the warfighter versus just off-the-shelf performance. The focus should be reliability lasting long into the platform life cycle. This will help ensure that maintainers' jobs are easier with respect to aircraft availability and that our warfighters have systems that meet their mission needs.
You nailed it. As the maintenance officer, I just want cables that work reliably all the time. Once they're installed, I want to forget about them, and I know that I won't have to continuously inspect them and replace them. I'm really wondering if we can get there.
At the OEM level, you basically only have supplier qualification data mapped to MIL standards. In-house testing is generally limited to a lab or SIL. There definitely needs to be a better way to define specs, especially with respect to including requirements that are directly relevant to the end-user maintenance environment.
Absolutely. Specs that take into account the real challenges at the squadron level will definitely allow the maintainers to minimize their focus on cable repair and replacement. And that will definitely make it easier to keep the aircraft on the ramp, ready to go at any time for any mission.
What does it take to improve aircraft availability and achieve operational readiness? For microwave RF cables, this would mean that 100% are passing OEM specification and the systems are full mission capable. What does the maintenance officer need to achieve this? Here at Gore, we refer to this as a fit and forget solution. What do we mean by fit and forget? Fit is the ability to perform within OEM specification after the cable installation process. This includes overcoming the challenges involved, such as space constraints, weight sensitivity, and performance evaluation throughout initial integration or in-service replacement. Forget about the need to replace a cable. It will perform in rigorous flight conditions of dynamic stress, contamination, and environmental extremes over the platform's service life. It will endure direct and indirect maintenance activities without being damaged. Think of it as being invisible. Goreflight microwave assemblies are lightweight, flexible, durable, and exceed today's military standards. Our microwave assemblies improve all aspects of protection and performance, ensuring mission-critical success after installation, during use, and over time, increasing operational readiness. Think of it as being invisible. Goreflight microwave assemblies have the following benefits. Electrically, they provide the lowest insertion loss and reduce RF interference. In the field, they deliver lower installation costs and longer system life with reduced downtime due to their mechanical robustness. Their lightweight design improves fuel efficiency and increases payload. They're also proven to be compliant with the requirements of MIL-T 81490, the military specification for transmission lines intended for airborne use. Finally, they deliver superior phase tracking stability over wide temperature ranges from -65 degrees C up to 200 degrees C. Goreflight was specifically engineered for mission success. While designing this product, we focus on end-user needs of a cable assembly that would survive installation and last for the lifetime of the mission-critical system. We try to keep in mind that it needs to work the first time and all the time. It all starts with a high-quality coaxial core. Therefore, the first 3 layers of the cable are the most critical. The center conductor, Gore's EPTFE dielectric and helically wrapped outer conductor, define the cable's electrical performance. The use of these proprietary material sets and application techniques allow Gore to achieve industry-leading cable performance. To ensure reliable signal integrity is maintained throughout the service life, Gore adds additional mechanical, environmental, and abrasion protection layers to the cable. For environmental protection, the vapor barrier adds near-hermetic sealing, and the liquid barrier provides resistance to chemicals and other contaminants. For mechanical strength, a braid and crush protection layer are added. The high-strength braided outer jacket offers abrasion resistance. These are the aspects that led to it being the Military and Aerospace 2016 Innovators Awards Platinum honoree. But how did we prove that our product was truly fit and forget? At Gore, we designed an airframe installation simulator to address a potential gap in the MIL-T 81490 standard with regard to surviving installation and maintenance activities. We asked our customers what features were typical on their airframe that could damage microwave RF cables and ultimately lead to system failure. They told us that cables were pulled through bulkheads with tension by the connector, bent up to and sometimes beyond their minimum bend radius, scraped against sharp edges, and finally, tightly clamped together. We then designed our installation simulator to incorporate these features. In the image, you'll notice 4 mandrels set to the minimum bend radius of the cable. You'll also notice routes and guides to induce torque, as well as an offset abrasion edge to scrape against the cable jacket. Once the cable is routed through these features, the user then pulls the cable the rest of the way through, with approximately 30 to 40 pounds of tension. The cable's electrical performance then needs to be tested to ensure that it remains within specification. Critical electrical parameters such as insertion loss and VSWR serve as the baseline to evaluate any performance change. The test conducted with the airframe installation simulator used Goreflight microwave assemblies in a direct comparison to the leading industry competitors' airframe assemblies. For the data displayed over the next few slides, Goreflight microwave assemblies data will be displayed in the color purple, along with the leading competitor in blue. Insertion loss before installation. As I just mentioned, OEM specifications for critical microwave RF cables will always include requirements for insertion loss and VSWR over the applicable frequency band at a minimum. It is important to understand both the out-of-the-box performance and the post-install or maintenance performance to see if any degradation occurred. We'll start by looking at the insertion loss data. Insertion loss is a measurement of the loss in signal strength as it travels from the input to the output connector of a transmission line, in this case, a cable assembly. Here's the actual insertion loss test data before installation of a Goreflight microwave assembly compared to the leading competitor. The purple line shown here indicates the insertion loss of Goreflight from the megahertz range up to 18 gigahertz. The blue line indicates the insertion loss of the leading competitor. You can see that when the assemblies are brand new and out of the box, they both have comparable performance and would meet similar specifications. Also, you'll notice that there are no spikes in the data and the curves are smooth. Insertion loss after installation. Now let's compare the same 2 cable assemblies after they've been routed through the installation simulator. As you can see, the results show that Gore's cable assembly maintained lower insertion loss with a smooth trace across the frequency band, providing stable and accurate system performance after installation. We even routed it through the simulator 3 times to prove that it could handle multiple installs and maintenance. In comparison, after only 2 cycles, the insertion loss of the leading competitor assembly shows a dramatic change with a marked degradation and various amplitude spikes. Results indicate a cable with unstable performance after installation. It's clear that physical damage has occurred to the cable shown in the post-install insertion loss data through 18 GHz and now fail specification, shown in red. VSWR before installation. Equally important to insertion loss, the VSWR, or voltage standing wave ratio, is a measure of accumulated reflections in a cable assembly over the frequency band. Simply put, if a signal is reflected back to its source, it will not reach its destination. These reflections are caused by impedance discontinuities down the length of the cable assembly. In the ideal world, if the impedance was a consistent 50 ohms down the length of the assembly, then the VSWR would be 1:1, meaning there are no reflections. Typically, for these types of airframe cable assemblies, a VSWR of 1.4:1 through 18 GHz is considered acceptable and would pass most specifications. As before, the purple line on the graph indicates the performance of Goreflight microwave assemblies, while the blue line indicates the performance of the leading competitor airframe assembly. Similar to the results we saw in the insertion loss prior to installation, they have comparable performance when fresh out of the box and pass specification. VSWR after installation. However, like the insertion loss results, we see severe degradation in VSWR after installation. This is the reason why it is critical for microwave RF cable assemblies to be retested for insertion and VSWR to prove compliance to OEM specifications. The Goreflight trace effectively shows no change through 18 GHz. Unfortunately for the leading competitor, their assemblies begin to experience spikes and broadband failure starting at around 7 GHz. This assembly has become unstable and fails specification. The installation process has imparted physical damage to the core structure of that coaxial cable assembly in the form of crushing the outer conductor at multiple locations. These crushed locations led to discontinuities, which caused the reflections to stack up at given frequencies, creating the spikes as well as an overall broadband increase in VSWR. Remember that if these signals are reflected back to the source, they will not reach their destination. To illustrate this further, we will show again the insertion loss and compare it to the VSWR after installation. Looking at the blue traces of the leading competitors' assemblies, you can clearly see that the VSWR spikes correlate to the insertion loss spikes at their given frequencies. Since the signal strength is now lower at those frequencies, we're most likely failing specification, and even worse, potentially creating system blind spots. This reinforces the diagnosis that the leading competitor's cable assemblies has suffered damage caused by bending, torsion, and pull forces. Where such a cable failure would be detected in the field by the squadron, the maintenance officer would have no choice but to test and replace the cable to bring the aircraft back to full mission capability. Jim, how do you think we can better share ownership for mission system success?
Obviously, there is a need for effective products and solutions to ensure that microwave RF cables are delivering the required performance levels, but equally important are the conversations and harmonization between the maintenance teams, PMO and OEMs that collectively meet the standards and also drive overall performance. Ultimately, the commitment should always be to give the military the best solution possible and the ability to complete their mission successfully and safely. Earlier in the webinar, we introduced the paradox that we see existing between a cable specification developed by the OEM and the post-install performance that creates a systemic challenge for microwave RF cabling to provide overall mission success. And as we said on the previous slide, we now see the opportunity to unlock the paradox. The key is improved communication between those responsible for mission system success, equipping everyone to be more knowledgeable, collaborative, adaptive and responsive to the continuing challenges of operational capability and availability. Improving communication and collaboration isn't a new concept, but it's not well practiced. Moving forward, compliance to electrical specifications and MIL standards will still be important. But introducing a mindset to build to sustain and increasing the time between maintenance activities at the outset of system development will provide real benefits to our military. Limiting maintenance activities on cable assemblies to periodic testing only, without the need to continually replace them, will improve mission capability, availability, and ultimately reduce costs for you, the taxpayer. Of course, the OEM has to have at his disposal the products that will deliver these benefits to the maintenance officer and his squadron. Goreflight microwave assemblies are the solution that helps to unlock the paradox.
An example of Gore improving aircraft availability, Steve Blasey, Director of Aviation Maintenance Support Office, stated, "Gore jumped in and supported us when we were having some serious maintenance issues with these cables. We are impressed that we have yet to have a failure on a cable set that was routinely failing us. ASC is a mission requirement, and improved reliability equates to improved availability." Beyond just choosing a product, it's important to choose a partner. Gore has a 40-plus year heritage and extensive experience in aerospace applications. We have proven product performance both through simulations and on aircraft activities, supporting our fit and forget philosophy. Gore's products are qualified across multiple platforms, consistently performing over time. Our focus is working with customers to ensure they have the right solution for their application. And of course, we encourage you to perform your own trade studies and to get real data. A copy of this webinar, both audio, slide, and a podcast version are available by going to gore.com/missioncritical. Here you will also find easy access to more technical information about Goreflight microwave assemblies, including a white paper, datasheet, and online tools such as our calculator and cable builder. We also encourage you to share the link and promote the mission-critical subject to your colleagues. Thank you for listening. We hope you found this presentation interesting and informative. A selection of the Q&A session from the live webinar is available on the page below.